Welcome to Lecture 4, the blinking LED. A light-emitting diode is a special kind of a diode in that it can emit light. Although all diodes do emit light, in most cases this light is not bright enough so we can't see it. LEDs are specially constructed to allow the light produced to escape outwards so we can see it instead of just being absorbed by the semiconductor. A diode is a polarized device. In a polarized device, there is a correct way and an incorrect way of connecting it to your circuit. Connecting a polarized device to your circuit incorrectly will at least result in your device not working. In some cases, the device can burn out. Notice that in an LED, there is a short leg and a long leg. The short leg is called the cathode, often noted with a K, and should be connected to the negative voltage. The longer leg is called an anode and noted with an A and should be connected to the positive voltage. Other devices that are polarized and use similar or same terminology are transistors and certain types of capacitors. Symbolically, an LED is depicted like this. The basic characteristics of a diode is that it is a semiconductor device that allows the flow of electricity only towards one direction. Think of it as the equivalent of a plumbing valve that allows water to flow only in one direction. Therefore, diodes are used in situations where we want to restrict the directionality of electricity. Diodes are used extensively in applications like the conversion of current from alternating to direct in radio transmitters, for the modulation of signals, and many others. For an LED, the only difference is the presence of arrows which show that light is emitted from an LED. With the background and theory behind us, let's implement our first Arduino circuit. The aim is to become familiar with plugging components into the breadboard, uploading, and running a sketch. In our first sketch, we will simply make an LED blink on and off. Here is a diagram of the circuit you need to build now. Start by taking a red jumper cable and connecting it to Arduino socket number 9. The other end of the cable should go to any socket in an empty column on the breadboard. Let's name this column number 1. Take a 220 ohm resistor or close to that value and connect one pin in one of the sockets of column 2. And the other one will go in an empty socket in column 3. Connecting our resistor in series with an LED is important because the LED does not offer much resistance to electricity. Connecting an LED directly to power will cause a high current to flow through it and quickly burn it. Now here is a tricky part that has to do with connecting the LED in accordance with its polarity. Take the LED, find its long leg, and plug it into an empty socket in column 1. This socket conveys the positive voltage. Plug the other leg into an empty socket in column 2. An easy mnemonic rule to help you remember how to connect an LED is that the long leg must be connected to higher voltage. Finally, use a black jumper wire to connect the Arduino's ground GND socket to an empty socket in column 3. So this is what your circuit should look like after you connect all the cables together. get the LED to do anything, we need to set up the sketch and upload it to the Arduino. This is the program that we'll be uploading to the Arduino. I'll explain how it works since this is our first program. Any text following the double slashes or is in between slash star and star slash is a comment, and the Arduino will ignore it. People use these symbols to type comments like in these examples. An Arduino program can be broken down in parts by using functions. Functions make it easy to create little programs within a large program and to call each of these programs by name. In this example, we used two functions with names setup and loop. These are special functions that the Arduino will call itself. When the Arduino starts, it will first call the setup method and execute any commands it finds inside. Then it will call loop again and again until you turn off power, every time executing whatever commands it finds inside. You can create your own functions and name them whatever you like, as long as you don't use a reserved name like loop or setup. Function names can't have white spaces or other special characters inside them. A function may or may not return a value when it finishes its execution. Notice that loop is declared as void loop. The void means that loop does not return anything when it finishes its execution. Same thing happens with setup. If you want to store and retrieve values in your sketch, you need to use variables. Variables can store numbers, text, booleans, and other data types. In the very beginning of this example, we have this statement, int LED equals 9. This creates a global variable named LED and stores the value 9 in it, which is of type int, integer. A global variable is accessible from anywhere in your sketch. In this example, you can see that inside the setup function, there is a reference to LED, and similarly, there is a reference to LED from inside the loop function. On the other hand, a local variable is one that is only accessible from within its own context. If we had declared the LED variable inside the setup function, then it would only be accessible by other statements inside the setup function and would not be accessible from the loop function. Arduino's magic is also in the functions that are built into the language. These functions make it easy to control many aspects of a hardware. Notice that in the setup function, there is a call to the function pin mode. This function takes in two parameters. First, the number of the pin we want to configure, and second, the mode that we want to assign to this pin. In our example, we have pin mode LED, output. Remember that we have a global variable called LED in which we stored the number 9. So we can rewrite the pin mode instruction as pin mode 9, output. This means that we configure pin 9, which is digital pin, with possible states high and low, to be an output. Being an output, this pin can be used to send a value to a connected device, in our case, the LED. With the setup function complete, the Arduino then starts calling the loop function. The first thing that happens there is calling the digital write function. Digital write, parenthesis LED, high, close parenthesis. With digital write, we assign a new state to a pin. We can rewrite this statement as digital write, parenthesis 9, high, close parenthesis. And as you can probably guess, we are changing the state of pin 9 to high, which is 5 volts. As soon as this happens, your LED will light up. We want to keep this LED lit for a little while, so we use the instruction delay to keep things as they are. Delay accepts one parameter, that is the number of milliseconds to wait for. So in our case, delay 1000 means wait for 1000 milliseconds, which is 1 second. Then we call digital write again, but this time we change the state of pin 9 to low, which is 0 volts. Digital write, parenthesis 9, low. We wait at this state for another second, then the loop starts all over again. So there you have it, the first Arduino circuit and the blinking LED. In the next lecture, we will make the same LED using the exact same circuit fade on and off, giving us a much nicer visual effect to look at. Before that, please complete the Lecture 4 quiz questions.